Hey, this is Mark, and I'm going to discuss the Wanhao Duplicator i3 desktop 3D printer today. And I'm going to talk about problems I ran into so that you can avoid them if you buy one of these printers. It's a really awesome printer. I got this from Wanhao USA, or is it, I forget, I think it's wanhaousa.com. It's a 3D printing site that's basically just a distributor for Wanhao printers. And there are several kinds of printers. This is a Duplicator i3, and it's a bit messy. You can see I have a lot of tools, and it has parts that have been modified, and we're going to discuss all the problems that I've come across so far in 2 months. In 2 months, it's looking horrible, but it's actually a really good printer, and I plan to get this up and running again soon, hopefully. But now Wanhao USA has a 1-year warranty for this, parts and labor. Sounds really good, but we're going to talk about that later when we talk about the problems I ran into. Now you can see here, this is the main board inside, and it's fairly simple. You know, there's just some connectors that go to the board to control the stepper motors. There's also a USB and mini SD input area, which connects into the side here into one of these. So you can basically take one of these little micro SD adapters, and you can put this into your computer, and the card is really small, you can see. And these come preloaded with a few things on them, so when you get them, if you put it on your computer, you can actually get a simple manual for the printer as well as a printable hand. Okay, so just for everybody's, for the sake of eliminating your frustration, this printer is very frustrating. There are issues with it, and we're going to discuss those because the issues I ran into with this printer are enough to drive you crazy if you don't know what you're doing at first. And one of the first things that I noticed was the rods here were loose when I got this in the mail. And so the first thing I would suggest if you buy a Wanhao Duplicator i3 is to go through, take the Allen wrenches, Allen keys, go through and tighten every single screw that is on the entire duplicator. This little coupling that goes in between here and here has some set screws on the inside there, and I really can't, let me see, you might be able to see it here, where there's a screw that goes right through that round piece. It's really hard to tell, and I'm sorry about the lighting, but if these are loose, what happens is when you're printing, you will get like a stair-stepping in your prints. I've seen a lot of people with that problem, and a lot of people have problems where a print will, if you're printing this like my finger, you know, it'll be like sliced in the center and off center, like halfway through the print. And that's a lot of the times because these things here, these rods are just loose from shipping. First thing you should do is definitely go through and tighten as many screws as you can. You know, turn your printer upside down if you need to. Look underneath. There's a lot of screws, you know, set screws and things which are hard to get at. So just go through and front and back, up, you know, bottom to top, tighten every single screw because otherwise it might not work for you. The major problem that you'll probably run into are clogs, and so what we're using here is this filament, which is 1.75 millimeters in diameter, and it goes inside the top of your extruder here into a hole. And when it goes down inside, there's a tube inside there, and trying to push it through for the first time is pretty easy. You just press down on this lever as you push your filament inside. Okay. Then you want to you can preheat your extruder using this button, which I can't show you guys because it's all taken apart. I don't want to plug it in right now. But if you preheat it, you can push your filament through. The way it works is really simple. We have these two wires which go into a resistor that fits inside of this aluminum heating block. And this is one of the problems I ran into. The first problem I ran into when I had a clog was I didn't really know how to take all this apart. And when I did take it apart, I actually did some damage to it. If you don't know this, you're going to have a problem. So that is that there is a set screw that is hidden underneath the bottom here that tightens down on your little heating element. So what I was doing was I took the heating block off, and in doing so, these wires were naturally bending maybe too much right here where it connected to the heating element itself. And when I put in a new nozzle, I had a new nozzle that I put in there. This is a Swiss nozzle, all metal, and I put it in there, and this wire snapped by itself. You know, well, I did it, right? But it was weakened from you know, trying to screw the parts in there and everything, and this snapped. And so I've had to resolder in, to buy and resolder in a new wire and heating element. So the first thing I want to tell you guys is if you're going to take your parts apart, first thing you should always do is take your little Allen wrench, stick it underneath there, and loosen this and pull this out carefully, and you want to pull it straight out. So let me loosen it now and I'll show you. Alright, so I can't really stress this enough. Now I've loosened that Allen, the set screw with the Allen key, and then I'm going to pull this out. I'm going to pull it straight out like this, very carefully. Okay. You don't want to bend these wires if you have, you know, if you can get around having to do so. You don't want to bend them because they will eventually weaken, especially by repeatedly taking these apart. So that's the first thing you want to do. Also, this is a replacement thermistor, which do not try to wire yours up like this. My thermistor, which is here, we're going to talk about this. But essentially, there's it looks just like this, but what they did is this used to be alright, so here's your thermistor. It used to be soldered into these wires here, and then this whole assembly would be plugged into the white wires here. Now there's no polarity to this, so you can just plug it in this way or this way. Doesn't actually matter. And a thermistor reads the temperature, for those who don't know. And this is actually not a very good, they didn't have it designed well, and so we're going to get to that in a minute. But when you take apart all this, these are the first things you should remove. And the thermistor goes into a hole in your heating block, like this. And then when it's in this hole, right, this small hole that's not threaded. See if I can get it in there. You can see it's very hard to do this because it's small and I'm using one hand, but goes in there. And then from there, there is a small screw and washer that gets threaded into the hole next to it. And when it's in there, it tightens down onto the whole thing and holds it in place. And this is actually not a good design. And they actually mention that you will get an error on your printer on the LCD that says DEF. When you see that, something is wrong with your thermistor. And I had this problem and I didn't know why at first. And so I brought new thermistors thinking I could wire, you know, put it in there, and maybe it was just the thermistor that was bad. That wasn't the case. I'm going to get to that in a minute, but essentially this is how it goes in there. So you want to unscrew, if you're going to take your hot end apart to clear a clog, or it's not extruding and you have to take it apart, you want to take these two parts out very carefully. So we've got our heating element, our little resistor, and our thermistor. So we want to take it out. You unscrew it, pull it out, and you can even, you know, unplug it for more, you know, security if you don't want to screw up your parts. I would kind of recommend that. So when these are out, the next thing you want to do is you want to take your Allen keys. Oh, my cat's having a bad dream over there. And you want to loosen the fan. And you want to take these screws out all the way. And this is the proper way to take apart your extruder, okay? So if you don't follow these steps, you could really screw it up. Which is what I did, so this is why I'm kind of making this video. So I'm going to loosen these up. Just say it's hard to see, but there's only 2 screws, okay? One here. I'm pretty sure that one's all the way out. One here. Okay, so that comes out like that. Basically, the fan has 2 little PTFE plastic pieces that are in there. So if you take these screws out all the way, they fall out. It's kind of annoying, but you can see how that basically goes right into these 2 holes. It comes straight out. You want to put your fan down. Put the light here. And here's what it looks like. This is basically it. And you can see where the thermistor goes inside of your block. Like I said before, you take the screw out and it comes straight out. So your thermistor goes into this little hole here, and this gets screwed into here. Now I put Kapton tape on the rear side of this washer for a reason, and Kapton tape around this entire block, and that holds in the heat. Also makes it less likely to make a short, and that's what I ran into. And so anyway, here you can see what the where your filament goes into. And this is the little gear that spins, and as it spins, it pulls the filament down in a downward position. And let me take off this, and from there it pushes the filament down into your nozzle. And this is a tube, goes down in there, goes through a hole all the way down to the base of this nozzle here. Okay, so let's say we have a clog. Now I had a clog in mine and I didn't know what to do. When I first did this, I had the heating element in there, and so I didn't realize you could take it out, and I was twisting it, which is not a good idea. You want to first try to take this filament out by hand, and if it gets stuck, it'll be down inside your gear here, like this. And if this is down in there and it's clogged and you can't back this out, it attaches your stepper motor to this part. And that can be a source of frustration. So what you want to do is you want to take some wire cutters and you want to snip this right at the base, slow down as you can, turn on your printer, and you want to put the position of your extruder, you want to, in the settings, back this off so it will come out. And you can do that by twisting on your knob, and I can't show you guys, unfortunately, but that's how you would do it. So if you have a piece of wire sticking out here, you want to take it out, and then if you can, you want to take off your entire heating block. And to do that, there's another hole, which is right there. And you want to insert your hex screw or Allen key and loosen your hex screw in there until it catches, and loosen it. Now it's loose, And I can probably just pull this straight down, so let's try. So I'm gonna grab it here, and give it a twist, and there it is. Alright, so here is what it looks like. You can see where heating element goes, thermistor, and screw to hold it in place. And this here is what is this? A 0.4 millimeter nozzle. And this one, I can't remember where I brought it from. Really cool place, but so here it is. And so, what is inside here? When you get a clog, what do you do with this? That's the next question I had, because I didn't know. And I learned the hard way. I looked inside the hole, I'm like, where's there, you know, I had assumed that this was all metal inside, right? Because you would think, get super hot, it's melting plastic in there, what can I do to clean this up, and how do I take it apart? And I tried to unscrew it here, and I couldn't do that, and I couldn't unscrew it at the top, because the plastic had essentially fused everything into the block. And so what I did was I took a 1 millimeter drill bit, and I put it inside the hole, and I tried to clean it out this way, thinking, oh, it's metal, you know, I can't ruin anything because it's metal inside there. And so there was filament stuck in there, and this is actually a common problem with these printers in particular is, and the reason why filament gets stuck inside this tube is this tube here goes into this block, which is cooled by the fan. Okay, so the heat is mostly in the bottom because of the heating element in this block, and as the tube comes up top, it's cooled, and it's done with the side fan that I took off before, which goes there. And so we have this little cooling system that makes sure that heat doesn't creep up too high and melt your filament past this point, because if it does, it'll just be floppy and it won't be drawn down inside there. Okay, so that's the purpose. But so there are settings in Cura and other programs, slicing programs, where you can set your retraction. So what happens is, as the nozzle goes over your part and the filament's going inside, the filament goes down and it's pushed through by your gear, and it's laying down a layer of molten plastic, right? So when it hits an end point and it has to go across to the other side of the part again and lay down another row, what it's doing is the plastic is being pushed down to extrude it onto your part, and then the motor goes backwards just a little bit. It's called retraction. So it comes up, then it goes across and goes down again. And this is so you don't get a a stringy mess between here and here as your nozzle is going across the part and it's not laying down plastic. So you don't want to have plastic that keeps going down, because it'll just keep going down and down and down and down, and you'll have all these, like, it's kind of like hot glue, and you get like those little spider webs. Not a good thing. So the motor backs it out, and every time the motor backs out your filament through this tube, okay, so it's in there, and it's pulling it back out so that it's sucking some of that molten plastic back up into the tube itself. As it does that, it creeps up and it gets cooled, causing a jam right here. Well, not actually towards the top, but somewhere about in the center there of that tube. So you're going to run into this problem with this printer, like I did for sure. Everybody does, because as you're playing with the settings, it becomes a major problem. So we're going to take this apart, and I'm going to show you what's inside, so you don't make any mistakes like I did. So you can see we have the nozzle. Okay, this is it. It's made out of probably brass, some sort of brass. And then we have also inside, surprisingly, a piece of plastic, right? And you wouldn't expect there to be plastic inside of a tube that melts plastic. It makes no sense. But this plastic is a high temperature PTFE tubing. And this is where the clog is going to be, inside of here. So what you can do is you can pull this out. You can pull it out of there. And it goes up to about the top here, just under where that hole is, and stops. You can take your little hex key and you can put it in there, and you can try to push that out in either direction. Or you can actually buy somewhere around 4 feet of this tubing for about $5 on Amazon.com, and it's called PTFE tubing, and it's for RepRap MK10 nozzles. MK10 is the type of nozzle. You can either replace by cutting a piece of this and putting it back in there. Another way to clear clogs is to use the E string from a guitar. So if you go to a guitar shop, get an E string. It's a very fine wire, and it fits inside the nozzle. You try to push it out, any kind of clogs. And the final way you can do it is if there's a something in there, inside of here, you can take and a propane torch and just heat this up and burn out any plastic residue inside there. That I would do as a last resort. Same goes with this heating block, because you can melt it with a propane torch. So don't do that. But that's the basic way to clean up a nozzle. And there are people that sell, little drill bits that can go inside there, and those are probably awesome too. But what I found from my own experimenting, just by using the E string from the guitar and moving it in and out of this nozzle, which was clogged, let's see if I can, is that you will change the shape of that hole slightly. And it will be more oval shape from where you're scraping that E string, which is steel, into a brass nozzle. Okay? So you gotta be very careful with these. This is the first one that came with the printer, and you can see I didn't know what I was doing. It's kind of scratched up a bit. So I had to have a replacement. So that's how you clean a nozzle. You don't want to stick a drill bit inside of here like I did. You want to be very careful with that plastic tube inside there. The other alternative is to get a Swiss all-metal extruder nozzle and tube, which I brought. This thing here I tried, and it did not work well. It actually jammed up quite often. So I kind of prefer, just from my experience, using the original PTFE lined MK10 nozzle and tube here. That would be my personal preference. Okay, so now on to the big issue that I want to talk about so that you guys will not lose 90 bucks. And Wanhao USA, I told them what happened to my printer. I explained everything I did, and thanks to Jet Guy on the Google groups, we figured out that this wire here, which goes to the thermistor, should be reading 5 volts. Alright, now I was getting a DEF error message, and I got that DEF error message, which means that the thermistor was not reading the temperature inside of the heating block when it was inserted. Now the DEF message is because of I thought maybe this part, the thermistor, had a problem. And I found out that Wanhao did not properly solder these in place, and they fell out of their heat shrink tubing that they had connected to this here. This is a little plug that goes in here, and it goes to your thermistor. And so this is my replacement thermistor, so just ignore that bottom part, and just imagine that this here was soldered in there, and there's some black shrink tubing over that. So if you have this printer, you'll notice that, and you'll see it, and you'll see how it goes into your heating block here. So I changed my nozzle to the MK10 Swiss all metal nozzle and tube, so there's no PTF tubing inside there. It seemed logical that would be a better thing, but it turns out a lot of people run into problems with it. Some people have great success, just depends. it's kind of like a 50-50 gamble. So if you want to spend, you know, 35 bucks on it, you can try. But so the original thermistor was in the block, and I took it out and then put it back in the hole and tightened the entire assembly, and I got the DEF message when I turned my printer back on, and so I couldn't read what the temperature was from the resistor heating up my filament, and that's really important to know. So tried everything. I thought maybe it was this nozzle at first, because at first my prints were coming out where some layers would not be extruding properly. They would be like warm and cold. So so I thought, well, you know, what could it possibly be? And I thought, well, it's got to be the thermistor then. So I made sure it was soldered in place properly. I took it apart. I wiggled the wires. You know, I'm looking for any kind of shorts or breaks in the wire here. Couldn't find any problems at all. So that's when I brought some new thermistors. These are thermistors, which look different, from MakerGeeks.com. And now I didn't put any PTFE tubing on here, and so Jet Guy, I talked to him on Google Groups, and he said that I probably shorted out the board because of this. Now, I disagree with him. I did take a voltage reading on this wire between the copper pieces, and there's no voltage. And so this is some kind of coated wire, and from my very limited experience, here's some speaker wire. You can see is also copper in color, and it has insulation over it so that it can't short out. So I had assumed the same of these, and luckily, you know, because I don't feel as guilty as I thought I should, there was no voltage reading between these wires when they were sandwiched together. Because when you buy them from the manufacturer, they come sort of like, they look like this, and this, you can see the two wires are together, and there's a silver tips. So anyway, so I knew when I put this new thermistor in there, I was getting the same problem. I was also getting the same voltage reading from before and after, you know, when I had tried to repair it. So I tried to figure out, you know, go back in time and figure out how this could have been a problem. And since I was not getting 5 volts, I was getting 0.12 volts between these leads. Jet Guy said that the board was probably shorted out. So I thought, how did I short that out? You know, I thought, did I do this wrong? Did I do that wrong? So this was not the problem, and this happened after the fact when I tried to repair it. The only problem I could come up with is the thermistor. And what happens with this particular printer is, if you can see, okay, so you can see here the thermistor has PTFE tubing. It's a high temperature tubing, and it covers the leads right up to the base of the thermistor. And this thermistor, you can see from this angle, has to be bent. And when you bend it, it exposes the wires. Okay. Now when you put that inside of the hole of your heating block, for example like this, okay, and then what you do is you tighten that down with your screw and washer. That exposed piece of or that exposed edge there can touch the aluminum block, and when it does that, it shorts out your board. And so that's the problem. And so I found a solution to this, which I think everybody should do, regardless if you have a new printer or not. I really highly suggest that, first off, you want to take Kapton tape, and you can buy a sheet of it on Amazon.com. It comes in a manila envelope. And Kapton tape is essentially used to insulate your electronics. It's, you know, you peel it off the plastic, and it's just like regular tape. And you want to cover as much of your block as you can with that, especially where your thermistor goes in there. The same with you want to do with your washer that goes in the hole, because this is the backside of where the thermistor could potentially make an electrical connection. And Wanhao knows this is a problem. I know that they know it's a problem because they've got a video on how to avoid shorts, but they just basically say don't tighten it down too tight, you know, because you could break the wire. But that's not really where the problem is. The problem is that there's exposed wire right up there by the thermistor, and it's bending and it's touching the inside of your aluminum block. So the solution, if you can, is to get some PTFE tubing, buy some, and you want to either you want to cover the tip of your thermistor and come down a few millimeters. I don't know if you can really see this. See if I can. It's too bright probably. But you want to cover your thermistor and come down over it just a few millimeters and make sure that that bend doesn't have any exposed wire. So what happens when this happens to you is, sad to say, Wanhao USA does not consider that something they can cover under their warranty. So essentially the design is poor, you know, it's a poor design, the way that they've got the thermistor in here, and it's angled forward towards the heating block, and it's very flimsily in there. It's just not, it's unfortunate, you know, that customers have to suffer because of the design process, and when you take something apart, it breaks very easily. And there's just, you know, it's a simple solution. Just cover that up with PTFE tubing, or you can use a very small piece of Kapton tape and just wrap it right around this area, just slightly. The other thing I would suggest is when you put your thermistor in the hole, is not to rely on your washer and screw to hold it in place, because if you squish it too much, you could break the wire, right? What you want to do is you want to actually hold it in place with Kapton tape, if possible. Now you can do fancy stuff like put silicone, special heat-resistant silicone in the hole and all that kind of stuff. But just for, you know, basic safety purposes for your printer, I would put Kapton tape and hold your thermistor in that way, because there's no electrical connection that you can make holding it in that way, whereas with metal parts such as the washer and screw you can. Now, unfortunately, my board is fried, at least just this part where the heating element or the temperature reading from my thermistor goes into the board. One of the circuits is fried and it won't read the temperature off the thermistor anymore. So since Wanhao USA won't cover the warranty on this, I had to pay $90 for this simple board. Yeah, so don't make the same mistakes I made, because they won't cover it in their warranty. Maybe you should, you know, I can't say you should play dumb, but in some ways it's kind of unfair, you know. I mean, you pay $400 for a thing, and you know, you just want to clear a nozzle clog or something, and then it costs you $90. So anyway, it's kind of frustrating, but that's the way it is, right? So gonna get a new board and get this thing working, but that's the basics of what not to do with your Wanhao Duplicator. Alright, so am I happy with this printer, and would I suggest you guys buy this printer? I definitely would. I've gotten some excellent prints out of it, and you can see here just one print of an armature skull that I worked on and designed, which I hope to print more of these when it gets up and running again. Now Wanhao, if you guys are watching, you guys are a cool company. I'm not really sure about the warranty thing, because I think there's, you know, obviously some design flaws, you can call them that, I guess, where I think maybe a solution to this would be to use a PTFE washer instead of a metal one, so no electrical connection can be made here, and it's also a softer plastic and probably less likely to damage your wires that go in there. Now if the tube was lined with PTFE as well, there'd be no possibility for shorts. And I think that would be an awesome thing if you guys could do that. But otherwise, you know, it's a good printer. It prints well. And if you guys are interested to learn more about this, I would highly suggest you guys visit the Google groups, and I'll put a link to that in the description so you guys can see some of the problems that people face and some of the solutions. Alright, happy printing!